This video will explain how to get your new chip spreader set up and ready to operate. The following items are shipped with each chip spreader: extra linkage rods for shortened truck hookup, parts manual, operation, maintenance, and safety manual, wiring diagram, hydraulic diagram, engine parts, and engine operator manual. Before we go into how to attach the hopper to the chip spreader, let's review some safety precautions for the operation. Before lifting the hopper, check to ensure that there are no overhead electrical lines within 10 feet of the crane boom. Never let anyone go under the hopper while it is suspended. Be sure that the hopper is well secured and rigged before the lifting operation is begun. Use only trained personnel in installing the hopper. Check to make sure that the area around the hopper is clear of personnel and equipment before lifting the hopper. Be sure that hands and feet are kept clear of potential pinch points on the front of the chip spreader during the installation. Now that we have reviewed the safety aspects of the operation, let's start to put the hopper on the front of the unit. Hook a chain or sling into each of the rear lifting eyes. Lift the hopper slowly. As you lift the hopper, it will rock forward. Be sure that no one is near the front of the hopper. As you near the front of the chip spreader, you will need 2 people, one on each end of the hopper to level it. Bring it in gently and lower it onto the hooks in the carrying arms. Be sure that it is completely on the arms before disconnecting the hoist. Attach the lifting device to the front lift attachment and slowly raise the hopper to the vertical position. You may have to pry the hopper slightly to one side or the other to allow the latch arms to enter the 2 slots. Install the hopper pins in front of the latch arms and install the lock pins and snap the ring down so that the lock pin cannot come out. Connect all of the hopper hoses per the parts book diagram. Wipe each half of the coupler clean before attaching. Dirt and contaminants can do major damage to the hydraulic system. Install the conveyor hoods and connect the electrical connections for the headlights and the auto conveyor switches. Connect the electrical connectors on the outboard side of the left conveyor. Now let's check the hopper gate adjustments and the spread rolls to ensure that they were not damaged in shipment. This screen shows the application rate set point, aggregate size, and the speed set point while standing still. When the chip spreader is powered down, the values currently on the screen are saved and returned the next time power is turned on. The speed set point is displayed while the chip spreader is not moving. Once the chip spreader is in motion, the actual speed is displayed. The speed feedback is generated by a magnetic pickup mounted on the motor output shaft, which generates pulses which the computer displays as feet per minute. Different configurations of these 3 values can be saved in one of 5 memory presets. The memory presets store an application rate set point, an aggregate, and a speed set point in one of the memory locations. The memory push button then restores the information stored in that location to the screen when activated. This allows the operator to switch between stored combinations with the push of a button as opposed to having to scroll the individual values. It is important to understand that the memory functions simply restore the selected values to the operator screen. If one of the values is changed while operating, such as the speed set point, the speed will change. The value stored in the memory will not change. Pressing the memory push button will restore the saved values and override the changed speed set point. To save information in a memory, adjust the application rate set point, the aggregate size, and the speed set point to values that will be commonly used together. When the values displayed on the screen are set to the desired values, press the Save push button. Select the location or memory the information is to be stored in by pressing the corresponding memory push button. The display will return to the main operator screen. As a check, press the memory push button the information was saved to. The display will then show the value saved in memory 5. To move to the next screen, press the scroll switch down. This screen shows the engine coolant temperature on the left, the engine oil pressure in the center, and the fuel remaining in the fuel tank on the right. To move to the next screen, press the scroll switch down. This screen shows the hydraulic oil temperature on the left, the engine RPM in the center, and the system voltage on the right. The right side will display battery voltage when the ignition is on, but the engine is not running. The voltage will increase to 13 to 15 volts when the engine is running. To move to the next screen, press the scroll switch down. This screen shows the hours on the machine on the left side and the feet chipped on the right side. When the ignition key is turned on but the engine is not running, the hours will not accumulate since the hour meter is started and stopped by an oil pressure switch. If the engine is shut down after running less than 6 minutes, the hour meter will not increase as it counts up in 6-minute increments. Once the engine is started, the hours will start to accumulate. The feet chipped will accumulate as long as the gate thumb switch is activated. Distance will not accumulate when traveling and not chipping. To reset to 0, press the cow switch up or down. You must push the scroll switch up to return to each previous screen, eventually returning to the top screen. A series of alarm functions are built into the computer. If an item sensed by the computer reaches its programmed alarm condition, the appropriate item will appear in the screen, regardless of what screen is currently displayed. In addition, an output is sent to the beeper and also to the warning light mounted on the upper part of the control box. The alarm points are as follows. Certain material conditions could require a calibration of the computer to ensure the application rate set point is equal to the actual application on the ground. It is important to understand that the aggregate is being calibrated and not the memory. For example, 3/8 chips are being saved in memory 1 with an application rate set point of 20 pounds per square yard, and also in memory 2 with an application rate of 8 pounds per square yard. The calibration of 3/8 chips will update both memories. The memory functions serve as a means to quickly change between frequently used operating parameters. If the set point on the display is dramatically different from the application on the ground, it is possible the incorrect aggregate has been selected. Assuming this is not the case, the following procedure should be used to calibrate the aggregate to correct the application rate information stored in the computer. The aggregate to be calibrated needs to be selected on the display. Set the application rate set point to the desired value. The speed set point should be set around 300 feet per minute. Using the canvas supplied, place on a flat surface, leaving plenty of room for the chip spreader to get up to speed. With the control handle in the full forward position to assure constant speed, drive the chip spreader forward to the canvas. Actuate the gate thumb switch about 10 feet before the material will hit the canvas to ensure the gate is in the correct position. Deactivate the gate thumb switch once the canvas is covered. Weigh the material and the canvas with the scale provided. Empty the canvas and weigh it empty. Subtract the empty canvas weight from the total weight to arrive at the pounds per square yard. On a variable hopper machine, this will need to be done for the left and right hopper. Do this a minimum of 3 times and average the values before making any changes. Compare the measured values against the application rate set point on the display to determine the calibration required for each hopper. As an example, assume the left hopper weighed in at 23.5 pounds and the right hopper weighed 18 pounds. Press the cal switch up or down to access the calibration screens. The right hopper measured 18 pounds and the set point is 20 pounds, meaning the right hopper is 2 pounds light. Press and hold the cal switch up until the pounds per square yard reads 2 pounds. Press the Save push button to store the calibration for the right hopper. The screen will reset to 0 once the Save push button is activated. Press the scroll switch down to access the calibration screen for the left hopper. The left hopper weighed 23.5 pounds at the application rate set point of 20 pounds per square yard. The measured weight is 3.5 pounds heavy compared to the set point. Press and hold the cal switch down until the pounds per square yard reads minus 3.5. Press the Save push button to store the calibration for the left hopper. The screen will reset to 0 once the push button is activated. The calibration for the left and right hoppers is now complete. To exit the calibration screens, press the scroll switch up 2 times to return to the main operator screen. The calibration screens can be exited at any time by pressing the scroll switch without changing the calibration. The calibration is changed and then saved only by pressing the Save push button. The calibration process may need to be repeated depending on the accuracy desired. The calibration process will correct both hoppers to spread very close to the application rate set point. While chipping, it may become evident that one side appears heavier or lighter than the other. This can be fine-tuned using the calibration process previously shown while chipping. If the left hopper appears lighter than the right, press the cal switch and scroll to the left calibration screen. Toggle the cal switch up to raise the rate slightly and press the Save push button. This will increase the output of the left hopper without affecting the right. The change will take effect as soon as the Save push button is activated and should be noticeable on the ground. This process can be repeated until the left and right hoppers appear the same. The calibration process is permanent, meaning when the machine is powered down, the changes will be saved for the next time the machine is put to use. The computer must be set up and the various sensors and valves calibrated for the particular chip spreader that the computer is installed in. This is normally done at the factory, and the settings are retained in the computer's non-volatile memory. Normally, an entire setup does not have to be done in the field. but if a pump, motor, proportional valve, or gate transducer is changed, that particular item would have to be recalibrated. In the case of the gate transducer, should be mechanically set using the procedures described under Hopper Gate Transducer Adjustment in the operator's manual before recalibrating the computer. In order to do that, you must enter the setup screens. If an item is already properly set, you can scroll by it to the next item until you get to the one that needs to be recalibrated. If any one item is changed, you must save it using the procedure described at the end of the various screens. The following screens are entered by holding the CAL switch either up or down while turning the ignition key on. These screens are used to configure the computer to the particular chip spreader and to calibrate the speed pickup, joystick, and gates. The first screen will appear when the ignition key is released from the start position. This screen shows the version of firmware which is loaded in the machine. Push the scroll switch down to move to the next screen. This screen shows which engine is in the machine and sets the TAC input for that manufacturer's engine. Use the CAL switch to toggle between Cummins and Caterpillar engines. Push the scroll switch down to move to the next screen. This screen is used to set the type of drive in the machine, either two-wheel or four-wheel drive. Use the CAL switch to toggle between two- and four-wheel drive. Push the scroll switch down to move to the next screen. This screen is used to set the motor displacement. Use the CAL switch to toggle between 107 cc's and 160 cc's. If the machine is a two-wheel drive, this must be set to 160 cc's. If it is a four-wheel drive, this must be set to 107 cc's. When this has been properly set, push the scroll switch down to move to the next screen. This screen is used to set the type of hopper installed on the machine. Use the CAL switch to toggle between fixed and variable hoppers. When this is set for your machine, push the scroll switch down to move to the next screen. This screen is used to set the display units to either English or metric. Use the CAL switch to toggle between English and metric units. When this is set for your machine, push the scroll switch down to move to the next screen. This screen is the entry screen for calibrating the joystick. It should say 0% with the stick in neutral. If the stick is pushed full forward, the reading should change to 100%. And if it is pulled fully back into reverse, the reading should change to -100%. If it does not, at any of these positions, place the stick in neutral. Be sure it is in neutral and then push the CAL switch. Once you have pushed the CAL switch, you must complete the sequence or you will have lost the existing calibration of the joystick. Push the CAL switch to calibrate the neutral position. Push the stick full forward. The reading should change to approximately 4.8 or 4.9 volts. When you have the stick fully forward, push the CAL switch to calibrate the full forward position of the control stick. Pull the stick to the full reverse position. The reading should change to approximately 4.8 or 4.9 volts. When you have the stick fully rearward, push the CAL switch to calibrate the full reverse position of the control stick. When you have finished calibrating the joystick, push the scroll switch down to change to the next screen. This screen is used to set the threshold current to the forward solenoid on the hydrostatic pump. This value should be set to 0.450 amps using the CAL switch. When it is set to this value, push the scroll switch to move to the next screen. This screen is used to set the threshold current to the reverse solenoid on the hydrostatic pump. This value should be set to 0.350 amps using the CAL switch. When it is set to this value, push the scroll switch to move to the next screen. The engine must be running, and you have to mark off 300 feet on a flat, straight surface. Put the chip spreader front wheel, or some part you can observe from the operator's seat, directly on the start mark of your measured 300 feet. Press the CAL switch up or down to enter the beginning of the calibration procedure and switch to the next screen. Press the CAL switch up or down to set the beginning of the 300 feet. Drive the chip spreader to the other end of the 300 feet and stop with the same reference point used at the beginning of the run. During the drive, the distance will count down on the display screen from 300 to 0. This is for reference only. Stop only when you have traveled the measured 300 feet. When you have stopped on the 300-foot mark, press the CAL switch either up or down to tell the computer that you have driven exactly 300 feet. When the CAL switch is activated at the end of the 300 feet, the speed pickup calibration is complete. Push the scroll switch to move to the next screen. This screen is used to set the actual closed position of the right gate. Be sure that the gate is actually closed. This number should read 0.0 inches. If this number is not 0, set it to 0 using the CAL switch. When it is set to this value, push the scroll switch to move to the next screen. This screen is used to set the full open position of the right gate. Press the right gate override button, and while holding the override button down, press the CAL switch. When the open position has been set, push the scroll switch down to move to the next screen. This screen is used to set the actual closed position of the left gate. Be sure that the gate is actually closed. This number should read 0.0 inches. If this number is not 0, set it to 0 using the CAL switch. When it is set to this value, push the scroll switch down to move to the next screen. This screen is used to set the full open position of the left gate. Depress the left gate override button, and while holding the override button down, depress the CAL switch. When the open position has been set, push the scroll switch down to move to the next screen. This screen is used to set the threshold current to the front motor. The threshold current normally does not need to be changed. It only might need to be changed if the chip spreader is set to be operated at extremely slow speeds, well under 100 feet per minute. Operate the chip spreader at 300 feet per minute. While the chip spreader is running at 300 feet per minute, increase the threshold current until a change in speed is felt, and then back it down until there is no speed change. The normal threshold current setting from the factory is 0.400 amps. When it is set to this value, push the scroll switch to move to the next screen. This screen is used to set the threshold current to the rear motor of a four-wheel drive chip spreader. The threshold current normally does not need to be changed. It only might need to be changed if the chip spreader is to be operated at extremely slow speeds, well under 100 feet per minute. Operate the chip spreader at 300 feet per minute. While the chip spreader is running at 300 feet per minute, increase the threshold current until a change in speed is felt, and then back it down until there is no speed change. The normal threshold current setting from the factory is 0.400 amps. When it is set to this value, push the scroll switch down to move to the next screen. calibration done in these setup screens is to adjust the open and close thresholds on the proportional valves controlling the gate cylinders. These thresholds determine the speeds at which the gates open and close and allow the operator to adjust them independently from side to side to make them open and close at the same speed. Use the cowl switch to toggle the current shown on this screen. Pushing the cowl switch up will increase the current, thus increasing the speed the gates moving from closed to open, while pushing the cowl switch down will decrease the current, thus decreasing the speed. Once any adjustments have been made, depress the right side of the rocker switch and push the control stick slightly out of neutral, opening the gate. Push the scroll switch down to move to the next screen. Use the cowl switch to toggle the current shown in this screen. Pushing the cowl switch up will increase the current, thus increasing the speed of the gates moving from open to close, while pushing the cowl switch down will decrease the current, thus decreasing the speed. Once any adjustments have been made, depress the left side of the rocker switch, closing the gate. Push the scroll switch down to move to the next screen. Use the cowl switch to toggle the current shown on this screen. Pushing the cowl switch up will increase the current, thus increasing the speed of the gates moving from closed to open, while pushing the cowl switch down will decrease the current, thus decreasing the speed. Once any adjustments have been made, depress the right side of the rocker switch and push the control stick slightly out of neutral, opening the gate. Push the scroll switch down to move to the next screen. Use the cowl switch to toggle the current shown in this screen. Pushing the cowl switch up will increase the current, thus increasing the speed of the gates moving from open to close, while pushing the cowl switch down will decrease the current, thus decreasing the speed. Once any adjustments have been made, depress the left side of the rocker switch, closing the gate. Push the scroll switch down to move to the next screen. Press the Save button to save the changes you made, or push the scroll switch down to exit without saving. Remember that if you changed only one thing, you must save as you exit, or that change will be lost.